Today I'm going to model for you how to add fractions with unequal denominators when there is actually a factor multiple relationship. So when you're adding fractions, the first thing that you need to look at are your denominators. In this case, we have the unit fraction 3 or thirds and the unit fraction 6's. So I'm going to write that. Let me erase this. So I'm going to put thirds first and 6's last. So it's 2/3 and 1/6. So what we're going to do is partition our tape diagram. Let me try to get that a little bit straighter. I'm going to partition our tape diagrams. Alright, so then I'm going to shade in. Let me label first. Put my unit fractions to let you know that I'm working with thirds. And I'm going to shade in 2/3. So there's 1/3. There's 2/3. So after I've identified and showed 2/3 as a picture or a model, I'm going to do 2 6's. Now, I start with thirds because we've talked about factors and multiples. We know that when we have multiple, we skip count. I know already by looking at 3 and 6 that there is a relationship. If I think back to my multiplication facts, I know that when I have 3 groups of 2, I get 6. So what I can do, since this is broken down into thirds, I can partition each third in half and create 6. So let me go ahead and label these as 1/6. So then I'm going to do the same thing, but I'm going to only shade in 1/6. So after I've done that, I'm going to use what I know, and I'm going to use See, Think, Wonder to help me analyze these two models. So I'm going to describe what I see. Well, I see that there are 2/3 shaded, and when I look at the 6's, I notice that if I partition my thirds, I can get a 6. So it makes me think that if I partition, it makes me think that if I partition the other thirds, I can get 6's as well. But even with thinking that, I'm wondering if what fraction is equivalent to 2 6's. So let me go ahead and look at this a little bit further. So if I partition each one, let me go ahead and partition. These no longer are thirds. They are now 6's. So I found what I was wondering. If I have 2 6's, let me write that up here. 2 6's is equivalent to 1/3. Now, does this change my fraction if I partition them? if 2/6 are equivalent to 1/3, that means that 2/6 plus 2/6 equals 4/6, and that 4/6 is equivalent to 2/3 based on my model. So, what does that mean? It means that when we're adding fractions, we cannot add fractions that do not have the same denominator. So I'm going to turn my problem vertically. It just makes it easier for me. Now, I'm going to point out something, that when there's a relationship between the two denominators, and we had been working on prime and composite numbers. If we look at the number 3, it is a prime number, meaning that there's only one way to create the number 3 through multiplication. But 6 is a little different because it's a composite number. And there's more than one way to create the number 6, which is 2 times 3 and 1 times 6. And when I'm saying there's a relationship, I'm saying that they both have the number 3 as a factor. So when two denominators have a number that's, a factor that's in common, or a common factor, you can create an equivalent fraction. In this fraction, it basically is just saying that only one of these denominators are going to change, because 6 is actually a multiple of 3. So therefore, we only change the 3, or the thirds, to 4/6. That 1/6 is going to stay the same, because 6 is a multiple of 3. That says that when we are skip counting 3, 6, that's the first multiple that we get to. And if you look back up here in the model, you'll notice that we were able to partition each one into 6s, but we didn't need to change 1/6 because it was already there. So let's go ahead and add 1, 2, 3, 4, 5. So 4/6 plus 1/6 is 5/6. And that's how we add fractions where there's a relationship between the both denominators. So now it's your turn to add fractions with unequal denominators. Because this is a word problem, we're going to use our problem solving strategy, which is read, draw, write. So in here, I'm going to put a read part, and then down here, I'm going to draw, put my D for draw. Alright, so let's read. Emiliano needs a 1/2 cup of butter to make cornbread and 1/4 cup of butter to make apple muffins. How many cups of butter does he need? So we're going to underline our question. So the question is asking us how many cups of butter does he need? So let me look back in the other sentence. Emiliano needs a 1/2 cup of butter. So I'm going to circle half, because they're asking us how many cups of butter does he need to make cornbread and 1/4 cup of butter to make apple muffins. So I'm going to circle that because they're asking us how many cups of butter does he need. So when I'm looking here, this how many it's asking for a total. So I need to determine what operation I'm going to use. So the four operations are multiplication, division, addition, and subtraction. Well, I know that addition and multiplication, they give us total, but I'm not going to multiply these fractions because I've only learned how to multiply whole numbers. So that means that I'm going to add these. So I'm going to add 1/2 plus 1/4. But guess what? I immediately notice that my half and my fourths are unequal, and I don't have the same denominators. So I know that I'm going to have to create fractions with the same denominators in order to add them. So I need to use a math tool, and the math tool that I'm going to use is my tape diagram. Alright, so my first fraction is 1/2. My second fraction is 1/4. So I'm going to partition this one into half. I'm going to partition this one into fourths. So I notice, go ahead and label these before I go on. Alright, so I notice that the parts are unequal. So I'm going to go ahead and shade in 1/2. And 1/4. But I noticed something that I learned in the previous lesson, that when I can partition my halves and fourths, and I can create equivalent fractions. But I also noticed that what I do to my shaded part, I must do to the rest of the fraction. So I no longer have halves, I now have fourths. But my 1/2 is no longer 1/2. My shaded part is now 2/4. So now I need to add these up. I'm going to turn these 2/4 plus 1/4. So 2/4 plus 1/4 equals 3/4. So the way that we add these up, we just say 1/4, 1, 2, 3/4. So we only add the shaded part. And so our last part is the right part. The question asks, how many cups of butter does he need? Emiliano needs 3/4 cups of butter.